of the first particular process is made by metal. Metals are, in regard to form, immediate, indifferent corporealities in which distinct properties are as yet undeveloped and concentrated into the simple determination of specific gravity. Metals, the first kind of bodies, distinguished only inactively from one from the other, initiate the process by imparting to each other their immanent determinateness and difference. Through this compact unity of their nature, they are in principle fluid and are conductors of heat and electricity. In doing so, they enter into a state of tension towards each other, for they are at the same time independent. The tension is thus still electrical, but in the neutral, hence separable medium of water in combination with air, their difference can actualize itself. Through the neutrality of water and hence of its real capacity for differentiation, the water may be pure or salt, etc., may be added to make it capable of a more concrete action. A real, not merely electrical activity develops between the metal in its state of tension and the water. With this, there is a transition from the electrical to the chemical process. Its production is oxidization generally and deoxidization or hydrogenation of the metal, if the process goes so far, or at least the generation of hydrogen gas and likewise oxygen gas. That is, a positing in abstract independent existence of the differences into which the neutral element has been sundered, just as at the same time their union with the base comes into existence in the oxide or hydrate, the second kind of corporeality.
So I guess one thing, I guess, is that at this time they still didn't know the process properly here yet.
Right.
Basically, this is just a wet battery. So it starts out on one end where you have a process starts consuming electrons. And
Yeah.
so that's one of the sides and leaves a bunch of anodes that then kind of go toward the other side
Yeah.
for one membrane. But that the fact it's consuming electrons means there's gaps and electrons start kind of filling in the gap like anything else, and that creates the flow of electricity.
Okay. So
Yeah.
speak to me as if I was a 5-year-old. I don't know how a wet battery works. Can you explain it to me? Like I know what the
Yeah.
inside roughly looks like, but I don't
Yeah,
know what happens as a process.
there are two different types of metal in there. And this is the part I was trying to review because I haven't done with this in a while.
Yeah.
Basically, one starts a chemical reaction that then sort of starts it kind of makes a negative kind of direction for things.
Mm-hmm.
So because the way electrons work in a metal, the electrons are flowing now to fill in the gaps that the chemistry is using. And so that's and then but on that side, because you got positive, that starts another chemical reaction that's the opposite.
Yeah.
And so you end up corroding the zinc and kind of building up the copper. And so that's why you get the outgassing that we're talking about here. It's because they're
Right.
opposite ends of the chemical reaction. So one does oxygen, one does hydrogen because of that. But of course, that's us knowing the process that it isn't the material themselves that's flowing. It's something that's a component or kind of related to the cohesion of the product again that they're
Go.
misunderstanding.
Okay. Go back.
Okay.
Simpler. If I took the battery out of my car and opened up the top, what would I see and what does it do?
Well, I guess it's chemical store of energy. When you put it together, it allows electricity to flow by a chemical reaction on both ends.
Okay. Okay.
I
And
just,
and and that's
yeah,
where you basically hook your electrical system into the battery and
yeah.
it takes the positive and the negative charges and
It
creates
allows the
creates a
connection.
DC. It's DC current, right?
Yeah.
Yep. Yeah.
It just kind of sits there and it can't do anything until it has some way of flowing.
Right. Okay.
And so I think it's just funny because at some later point, because we know it's electrons flowing, right? It's what electricity is.
Yeah. Yeah.
So something we'll get into later is they're trying an explanation of what that is at the time. And in this case, it reminds me of the other kind of, oh, there's something that flows up. In this case, like the components of the water somehow flow through the substance that allows it to be hydrogen one and oxygen on the other, is what
Ooh,
we'll get into.
here's an interesting question. Before I hook it up to my car, it's sitting on the shelf,
Yeah.
and it's brand new. It's doing its thing, but it's it's basic. Okay, so is it like a stabilized chemical process to where if it's not feeding out DC current, it stays inert until it's being
Well,
used
at
to
this point,
to
yes.
continue a chemical reaction in there
Yeah,
beyond.
because it's well sealed, yes. It
Okay,
doesn't react until it has the ability
it
to that
won't
electricity.
explode.
It no, it creates a it just creates a it's the difference between potential and kinetic,
Okay,
right? It
okay,
starts building up a potential because there is something, but then it just sits there because it can't discharge.
okay.
So as long as you
Oh,
keep the
and if the potential part doesn't discharge, then the chemical reactions inside stop
yeah,
temporarily.
yeah. It
Okay.
builds up to a point where it can't do anything else, but it can't
O-
it's not like pressurized or anything.
Okay.
It's like
Okay.
how
That
the
okay,
white
that makes
battery
sense.
always has a charge on it until you use it up.
Yeah. Okay.
Because alkaline batteries are also a wet cell.
Yeah. Yeah. I was just curious. I know nothing about how these things work. Uh, it's a hole in my knowledge. And so when you describe it in terms of what he's saying here, I get it. But I also like wonder like physically like what's going on with those bands of metal in there in the chemical solution,
Yeah, I need
you
to
know.
go through some of it again, but there is a kind of corrosion that does happen on one side because of it's being used, and the other side where it
Because I know
starts
with nuclear
absorbing.
fuel rods, there are similar processes, I guess. Although I could be wrong about that. I don't know.
Because I think that's just used to boil the water, right?
Yeah.
So yeah, it. I think because it's discharging, eventually it does turn into a more inert substance.
So the difference between a nuclear rod and like a wet battery piece of metal is that the nuclear rod works on its own when it's properly saturated, but the metal in the chemical battery has to be
Yeah, I
combined with the water or with the, whatever's the chemical in there.
yeah, I think with the nuclear rods too, there's a certain thing that they line up to make it more reactive together.
Yeah.
That it still happens, but you get it's neutrons at that point that it releases. I think.
Yeah,
I remember.
they stimulate it in
Yeah,
some way.
yeah. I'm trying to
Okay.
The nuclear
overcomplicate it.
reactor, they use like cadmium rods or something to moderate the flow of neutrons.
The
Yeah,
reaction. Yeah,
Yeah.
that's fascinating. That is so cool. Okay. So how far off is he in terms of his description? Because one thing I've noticed in Hegel is that
yeah.
when he gives main entries, very often, they're very ideal. But here he
Hmm.
skirts the line into what's actually going on in reality, like describing the process. And I find it fascinating that he can't just leave it at the level of idea, but
Well,
has to describe how you switch over it from the potential electrical into the actual chemical process that's going on. You know what I mean? And he highlights that a bit. He says there's a transition from the electrical to the chemical process.
yeah. And it's kind of interesting too when you think about it, because the chemical process allows the electrical process to be realized. So
Yes. Oh, so he has it backwards?
potentially, we're going to talk about metaphysical process versus a cause and effect
It's the
process.
it yeah, it because it's the mirror, because the ideal is the mirror of the
Yeah.
real, that then it looks backwards to us here, but it's actually just in
Yeah, it's
logical
just
order.
yeah,
Yeah,
it's just it's being
I
real.
got it.
It's going from abstract to realized.
Yes. Yes. Okay, I get that.
Although you could even technically you like a rubber rod with with a fur or something, you're swapping off electrons, you're getting a charge that way.
Yeah.
that's not quite a chemical reaction, but you are affecting the structure. So it's a proto-chemical process back to where you were
Mm.
before this.
Well, the electrical and the chemical are probably like in reality dialectically related. You can't have
Yeah,
one without the other.
that's where I
And
was thinking. That's a superposition, by the way.
yeah, there we go.
That's what I was saying earlier. That's a
Yeah.
clear superposition.
Yeah, you were. You were. That's awesome. Okay. All right. Carry on.
All right. Okay, on this exposition of the process, insofar as it is present in its first stage, there is no difficulty either in distinguishing between the electrical and chemical aspects of the process in general. Back when they were thought as separate,
Yeah.
or identical, neither in between. The galvanic process in particular, which well, I think he actually starts getting into here, so I'll leave it at that, or in grasping their connection. The physics persists in seeking only electricity in the galvanic process. Yeah, that's the reductionism. So that difference between the extremes in the middle term of the syllogism is grasped merely as a difference between dry and wet conductors. Extremes and middle term being alike classified as conductors. It is not necessary here to take account of further modifications of the process. Example, the extremes can be different fluids in the middle term of metal. In some cases, the form of electricity, as stated in the paragraph, can be held to and sometimes made to predominate, where sometimes the chemical action can be intensified. Also, as metals are so independent that they can be differentiated only by the help of water and other more concrete neutral substances, or by substances such as acids or alkalis, which are already in a state of chemical opposition. In order to pass over into oxides, the metalloids, by contrast, so lack independence as the differentiation is set off simply by contact with the air, oxidization, and which converts them into earths, etc. These and many, well, I forgot to set that up too.
Yeah.
There we
Yeah,
go.
absolutely. There we go. Yeah. Feel free.
Other processes do not alter the basic phenomenon of the galvanic process, which we shall call by its first well-deserved name, but on the contrary tend to confuse our treatment of it. The fundamental affliction which has killed a clear and simple treatment of the process, once its simple chemical character has been shown up in the voltaic pile, has been the concept of wet conductors. Yeah, just realized that's
Yeah.
not a thing I've ever heard until now. This has resulted in the ignoring, the giving up, or the conception of the simple empirical evident fact that water, the middle term of the process, is originally and manifestly active.
Yes.
As the as the universal solvent.
Yeah.
It is regarded not as active but as a passive conductor. With the consequence, electricity too is regarded as something complete in itself and as only flowing through water as it does through metals. Well, I mean, that's literally why it flows through water because of the metals.
Yeah. Exactly.
Yeah, for metals too are in the connection seen only as conductors and in comparison with water as first-class conductors. However, the active relationship of water and process ranging from the simplest relation, i.e. water being water in a single metal, to the complex relations arising from modified conditions is to be found demonstrated empirically yet with all the forced intuition and with the notion of a living natural activity. In Fall's work, the process of the galvanic circuit. Perhaps this higher demand addressed to the instinct of reason to grasp the course of the galvanic and electric processes as such, conceived as the totality of the natural activity, is responsible in part for the fact that the lesser demand vis-a-vis simply to make notice of empirically demonstrated facts have until now met with scant compliance. Yes, he just described one part, and it's sort of the thing.
Yeah.
Yeah,
The
one reason
process of the
for
galvanic circuit from Leipzig pole. Yeah.
yeah, I think one reason why he goes into all of his details is because this is very new science at that time he's
Yeah.
writing. So most of the readers were probably not up on galvanism. They might have
Yeah.
heard the word, but most of them probably didn't know it. Most of them probably would not have known those details.
I'm I'm very impressed by Hegel's uh, willingness to bring his teaching, his high school teaching ability to this subject and put it across in this manner, because you know it's very hard to cross the divide between the real descript, like a rundown experimental description, and then the metaphysical, um to try to organize this right, and it really works out. I'll be right back. 2 seconds.
Okay.
Keep going.
Okay. An outstanding example of ignoring of facts in the field is the idea of a decomposition of water into oxygen and hydrogen, where when the former appears at one pole and the battery in whose sphere of action the water is placed, and the latter as its opposite pole. In this idea, water is regarded as consisting of oxygen and hydrogen, and its decomposition is represented as happening as follows. From the pole where the oxygen is developed, the other constituent of water, hydrogen, is mysteriously transmitted across the medium, which still exists as water, to the opposite pole, and reciprocally, the oxygen is similarly transmitted from the pole where the hydrogen is developed to the opposite pole. That's what I was talking about earlier, where it's just weird. Also, the two gases are represented as passing through each other in their passage from one pole to another, to the other. Not only does the inherent fallacy of this concept pass unnoticed, but it is also overlooked that in dividing the material substance of the two portions of water, a division which is, however, so arranged that there is still a connection, but only by a metal conductor, the production of oxygen gas at one pole and of hydrogen gas at the other takes place in the same manner under conditions which render it impossible. This intrinsically groundless, mysterious passage of gases or molecules through each other to their respective sides. A similar ignoring of experience occurs in connection with the neutralization of an acid and an alkali when one is placed at an opposite pole to the other. Here, too, the neutralization of the alkali is represented as due to a portion of the acid being transferred to the alkali from the opposite pole, as conversely, the neutralization of the acid is represented as due to transfer of a portion of the alkali from the opposite side. Yet, when a litmus solution is placed between them, no trace can be perceived in this visible medium of any action, and consequently not of the presence of the acid where it supposedly passed through it. Yeah, I guess you can kind of see where it's just like polarized at one end, and between the two ends, somehow you think that, I guess because it also kind of came to light for me that they like think of water as literally made of hydrogen and oxygen gas instead of knowing the atoms underneath, which cause its completely different structure. So if you think it's just literally those are just kind of stuck to our gases are stuck together to be water, that you just decompose it back into the gases makes a lot more sense in this context. It is also in place here to mention that the treatment of water as a mere conductor of electricity, which the experience of the weaker action of the pile with such a medium than with other more concrete agents, has produced the original conclusion that, and I keep forgetting, I'm just going to have to translate this. Do I still have that up somewhere? Nope. Oh, I actually already still have that. That's not it. Okay. Two. No, that is it. I just happen to have it highlighted already. Pure water which conducts strong electricity, such as that which we generate with our ordinary machines, becomes almost an insulator for the weak forces of the electromotive apparatus. In this theory, the name of the voltaic pile. Only the obstinate adherence to a theory which can discard such consequences can have the audacity to make water an insulator of electricity. Yeah, at this point, you don't make. Wait a minute. Pure water which conducts strong electricity, such as which we generate with our ordinary machines, becomes almost an insulator for the weak forces of the voltaic pot. Okay, so they're thinking pure water as not pure water as we would think about it. Because distilled water is definitely not as not that conductive.
Yep.
But as regards the central feature of the theory, vis-a-vis the identification of electricity and chemical action, the difference between these two processes is so striking that the theory is almost forced to beat a retreat, and then soothes itself by admitting that this difference is inexplicable. Certainly it is. If an identification is presupposed, this very circumstance makes difference inexplicable. The difference, the identity of identity and difference. Yes. The superficiality and inadequacy of equating the chemical properties and relationships of bodies with positive and negative electricity should be at once plain. In comparison with chemical relationships, tied though those are to external conditions, example, temperature, and others relative, electrical phenomena are wholly transient, unstable, and liable to reverse by the slightest circumstance. Whereas also the bodies of one side of the chemical reaction, example acids, are exactly distinguished from each other by their quantitative and qualitative ratios of saturation by an alkali. In the case of the merely electrical opposition, even were this more stable, no such kind of distinction is possible. But even if the entire visible course of real material changed into the chemical process is ignored and attention fixed only on the product, it is impossible to avoid expressing surprise at the striking difference between this product and that electrical process after the previous identification of the two forms. Yeah, let me just go back through this again as well. Let me go ahead and get the translation. I will confine myself to quoting the naive expression of the surprise in Brazzuli's work, Essay of the Theory of Chemical Proportions. He says, however, a question arises here that cannot be resolved by any phenomenon analogous to the electrochemical discharge. The expression chemical combination is dropped in favor of discharge. They remain in this combination with a force that is superior to all those that can produce mechanical separation. Ordinary electrical phenomena do not enlighten us about the cause of the permanent union of bodies with such great force after the state of electrical opposition has been destroyed. Yeah, so that's basically focused so much on the electrical aspect of the volt pile that they're surprised at just chemical changes. The changes in specific gravity, cohesion, shape, color, etc., occurring in the chemical process and, in addition, in the acid, caustic, alkaline, and such, like properties, are all set aside and submerged in the abstraction of electricity. Let philosophy no more be reproached with its ignoring of particularity and its empty generalizations, when all the physical properties just mentioned can be disregarded in favor of positive and negative electricity. A former style of philosophy of nature potentialized, or rather, dissipated and attenuated the system and process of animal reproduction to magnetism and the vascular system to electricity. Such schematism was not more superficial than this reduction of concrete corporeal opposition to electricity. Yeah, the animal reproduction is akin to magnetism. I can see that. In a former case, such a summary method of dealing with concrete phenomena to the neglect by abstraction of their characteristic features was rightly rejected. Why not also in this present instance? There's a remaining point of difficulty. Second, There's a remaining point of difficulty in the difference between the concrete process and the abstract schema, vis-a-vis the strength of the combination of the substances formed into oxides, salts, etc., as a result of the chemical process. This strength, of course, offers a marked contrast to the result of the mere electrical discharge, which leaves the positively negatively charged bodies in just the same state, and so separate and uncombined as they were before during the process of being rubbed together, while the spark has disappeared. It is the spark which is really the result of the electrical process. It is with the spark, therefore, that the result of the chemical process should be compared in respect of the difficulty arising from the alleged likeness of the two processes. Should it not be possible to remove difficulty by assuming the positive and negative electricity to be combined in the discharged spark with the same strength as, say, acid and alkali are combined in the salt? The spark, however, has disappeared so that it can no longer be compared, but the main point is that a salt or oxide is manifestly a further resultant step than an electrical spark. The light and heat generated in the chemical process are also improperly ascribed to such a spark. Breluz Berzelius says the following about alleged difficulty. Okay. Is it the effect of a particular force inherent in atoms, like electrical polarization? I.e., is there not a difference between chemical and electrical action in bodies? Undoubtedly and obviously. Or is it an electrical property that is not perceptible in ordinary phenomena? I.e., as above, in strictly electrical phenomena. So, like chemistry isn't has a form of electricity that is not otherwise observable or something. That's what I'm taking from that. The question also is to be answered with a simple affirmative, vis-a-vis that is, in electricity as such, chemical action is not present, and is for that reason not perceptible, and that is only perceptible at the stage of chemical process. Yeah, he does say it right there. However, as regards to the first possibility that of a difference between chemical and electrical determination of a body, as Rulers rejoins, oh, come on. The permanence of the combination should not be subject to the influence of electricity. That is, two properties of a body, because they are different, must not stay in any kind of relation to each other. The specific gravity of metal is not to be connected with its oxidation, nor its metallic luster of color with its oxidation, neutralization, etc. It is, on the contrary, the commonest experience that the properties of bodies are essentially subject to the influence of the action and change of other properties. It is the dry abstraction of understanding that insists on complete separation and independence of properties which are different, even when they belong to the same body. As regards to the other possibility, vis-a-vis that electricity has the power to break up strong chemical compounds, though this power cannot be perceived in ordinary electricity, Berzelius observes. Sorry, I need to find this again. The restoration of electrical polarity should destroy even the strongest chemical combination. Introduces in supporting the specific instance of voltaic pile, here called an electrical battery, consists of 8 or 10 pairs of silver and zinc plates the size of 5 franc piece, which pile, with the aid of mercury, is able to decompose potash, i.e., to preserve the radical of potash in amalgam. The difficulty was caused by ordinary electricity not showing the power in question, is distinct from the action of a galvanic pile. Now, for ordinary electricity, there is substitute the action of such a pile with the simple modification it is called a battery electrique. Whereas previously the name for it in theory was apero electromoteur, which make sure those are as obvious as translations as I think. Electrical battery, which was originally called electromotor device. This turn of expression, however, is all too transparent and the proof too easily taken. In order to resolve the difficulty which stood in the way of identifying electricity and chemistry, once again, straightaway presupposes that the galvanic pile is merely an electrical apparatus and its activity merely the production of electricity. Yep. Yet again, Hegel taking the anti-reductionist stance.
Yeah, if there's a difference contained in a process, he's going to identify it and highlight it as much as possible rather than try to
Yeah.
reduce it.
It's both it's both in how they are different and the same, which in this
Yeah.
case we know they're the same process because it's the chemical like how electricity generates magnetism generates electricity. Here you have the chemical reaction generating the electrical reaction.
Yeah. DC.
Yeah, because they
Lit
didn't have AC generation yet, I don't think.
Lithium batteries work the same way, right? It's exactly the same thing.
It's
No?
Yeah.
not sort of, but not really. It's more of a here you have a chemical potential that discharges in what they call it, that's a primary battery, but they call it a secondary battery. It's more that you're able to push electrons when you're charging it to one side to make it high potential, and then you can let it discharge while it lets it flow to the other side as you use it. So there's still a storage and use up. It's just not one is chemically one direction only.
Hmm.
But otherwise, yeah, it moves around electrons from storage. It has stored potential to discharge, to kinetic use. But I guess that's the definition of a battery, anyways.
Mm-hmm.
Of course, because lithium, you're able to charge it. It's secondary. You're able to push electrons. That's why it's rechargeable.
Hmm.
And then, of course, now we get to the addition, which is super long. Um,
We don't have to go through all of it if it's just more detailing of the process that we've already sort of talked about.
yeah, pretty much. All the one thing is, but a third substance is required. Again,
Yeah.
it's sort of the in between. You can have the two metals do not react until you have this in between, which is the aqueous solutions of the acid and base. Again, they keep referring to alkali, which I know that's just called base today. Wonder when that changed.
It's just fascinating to me
Yeah,
that um so if you have alternating current, usually it's generated by a process that turns turbines or generators, whereas with DC, it requires a chemical process to generate the electricity.
Mm.
Or is that too simplified?
it's a little too
You
simplified,
can
but
you can generate DC with a generator.
Oh, okay.
it's just that more chemical reactions necessarily has one direction. Well, generators you're more in control of what you're doing. So it's what you're just doing whatever you're doing with it
Yeah.
Also, you
because
got to
it's
remember in Hegel's day, in Hegel's day, the only practical way for generating electric current was with a wet battery.
yeah.
Yeah.
I guess these days electromagnetic inductance can let you go like burn gas to generate electricity.
Yeah, it comes a little bit after his time. A little bit after his
Let me
time.
go play. Thanks.
Yeah, I guess one thing I haven't gotten to here yet is Hegel showing when they were testing trying to do the this galvanic process in like a resin enclosed environment. Couldn't get a reaction because and discovered it has to have air or in this case oxygen to react in the first place. Which makes sense because that's where some of the oxygen that's going in is actually coming from. It's not coming from the water, it's coming from the air.
Yeah.
And then of course another example is like when they call it the precious metals such as gold, silver, and platinum are not they're not oxidized when they heat up the air. Basically, they're very difficult to basically rust. and that when they do, you can just sort of reheat it and it burns out the rust and that becomes the metal again. Um, because like lead other metals are easily attacked by weak acids, and he's kind of coming again into here like it's precious because it does all this stuff, but a lot of that has to do not just with it being that kind of metal, but literally because it's like because of its makeup. Da-da-da. Even mercury was is like that, slightly oxidized. You can basically burn it off. Schelling, therefore, regards these four gold, silver, platinum, and mercury as precious metals because in them is posited the indifference of essence, gravity, and form cohesion. On the contrary, these metals are not to be regarded as precious in which form is most separated out in indifference with the essence, and in which selfhood or individuality is the predominant feature, as in iron, nor are the metals precious in which incompleteness of form vitiates the essence, making them impure and bad like lead, etc. This is not enough. It is not simply the high degree of continuity and solidity, but also their high specific gravity that makes them precious. Platinum, is its true, has a greater density than gold. And here's the
Four.
part where I'm not understanding, but
Okay.
it's the unity of
Go
several
play in your
metallic
room.
moments.
Right there.
Osmium, iridium, and
Yeah.
palladium, which platinum is its own metal, so this may
Mm-hmm.
be something else. Or they
Hmm.
just assumed it was made of other metals when it's just, I don't
Pall
know.
Palladium is the metal that Tony Stark used in Iron Man,
Yeah, it's funny.
which I have no idea if that's just fanciful magic or if it actually works. I don't know.
Yeah, I think that's just
Comic
magic.
comic book magic. Yeah.
Yeah, but it's like these. I noticed that these four are actually very near each other in the periodic table too.
Mm,
That's why they're so similar.
yeah.
Oh, where's
It's one of
Stephens,
those things that if I could go back to high school, if I could go back in time and go back to high school, I would totally like do more with chemistry than I did because I actually enjoyed chemistry, but I didn't I didn't go beyond first level chemistry. And then looking at it years later, I'm like there's a lot of
yeah,
interesting things to be done. Uh
organic chemistry alone is basically a specialization.
yeah, but like industrial chemistry is like a whole thing unto itself. Like you'll never be out of work, even if you lose one job. Someone else will be like, "Yeah, this guy knows what he's doing." Mm,
Yeah, we're showing maintain density stands in inverse ratio to cohesion.
mm,
This is true only for of some precious metals. Yeah, again, kind of say, people generalizing things too much that remove certain important contexts. Again, his anti-reductionism.
right.
If we put gold into contact with silver, copper, zinc, or silver into contact with zinc, and put a third substance between them, a drop of water, but there must be air too. We are at once have a process and one of considerable activity. This is a simple galvanic circuit.
Yeah.
Yeah, it's just sort of like, yeah, this difference between two metals and the ability to guess to start dissolving allows it to flow, and acids make it easier than just plain water, but water will work. Yeah, again, that's two opposites connected by a third in a syllogism.
here?
Yeah.
Charcoal can have a similar process, being able to do it on the tongue. I just trying to remember. Now, the activity galvanic process has its origin in the immanent
Go play in your room,
contradiction
honey.
which arises from the effort of each particularity to posit itself in
Go
the
play
other.
in your room.
Go play.
Yeah.
But the activity itself consists in the positing of the inner, merely implicit
Oh,
unity of these inner
yeah.
differences. In the galvanic process, electricity is still predominant since what is posited as different are metals, i.e., they are indifferent, independent existences which hold to themselves even in being changed. The very thing which characterizes electricity. On one side, there must be a negative pole, on the other, a positive one. Or in chemical terms, oxygen must be developed here and hydrogen there, which is a lot of chemical processes on Earth, yes. The phenomenon we associate in the conception of electrochemistry. Some physicists went so far to believe that electricity was tied to chemical action. Yes, Walt even said that electricity was only present when there was oxidization. It was properly objected to that when cat skin is rubbed on glass, electricity is produced without oxidization. Yeah, that's just a different form of generating electricity, right? The metal is neither dissolved nor decomposed by the chemical action, so that it proves to be a neutral substance in its own self. But the real difference exhibited by the metal in oxidation is a difference added to it, for the metal is combined with something else. The two metals are combined in the first instance without the existence of a middle term. The middle term is only notionally present in their contact. The real middle term is what the difference has to bring into existence. This term, which in the logical syllogism is the simple medius terminus, is a duality in nature itself. In this finite process, the mediating term, which is turned toward the two one-sided extremes, and from which these extremes are to integrate themselves, must be not merely a notional distinct substance, but its difference must actually exist. That is to say that it is precisely the middle term which must have a break in its existence. Galvanic action also requires the air of the atmosphere or oxygen gas. If the galvanic pile is insulated from the atmosphere, it remains inactive. And then show an experiment where that happened. Urged against Davy that beneath an air pump, still produces gas, though more feebly. This, however, is because air cannot be completely exhausted. It's very difficult to do a vacuum at this point. Yeah. The fact that the middle term is a duality explains why the activity is much intensified if, instead of sheets of cardboard cloth, hydrochloric acid or sal ammoniac is put between the metals. Such a mixture is already in itself chemically complex. And then the history of Galvani inventing and Volta explaining the galvanic pile,
Mm-hmm.
how it shows that it can be used to move muscles, even in like dead dissected frogs and such. Someone else found a large vigorous frogs. The mere contact of the leg with its nerve would produce jerks without this armature. According to them, with two like metals are used, the metallic stimulus can be evoked simply by breathing on one of them. Again, creating some kind of thermal electric effect. If two parts of one and the same nerve are covered by two different metals and connected by good conductors, will too produce convulsive movements. Again, another point. Good point here. This was the first form. It was called animal electricity because it was thought to be restricted to organisms.
Yep.
Mm.
Go ahead. If you want to talk about the history. Okay. Volta used metals instead of muscles and nerves, and he thus made up the galvanic batteries out of a whole number of such pairs and plates. Each pair has the opposite determinants of the following pair, but the activities pairs is summed up so that one end there's all negative and the other end is all positive activity, the middle being the point of indifference. Volta also distinguishes between wet conductors, water, and dry conductors, metal, as if nothing but electricity were present here. But the difference between water and metal is something quite different, and neither of them plays the part of a mere conductor. It is easy to separate electrical from the chemical activity. The greater surface area of the plates, the more brilliant the electrical spark produced. Yeah, then he starts getting more detail on that. The commuting wires are so. And oxygen, gold, silver behave as they do in atmospheric air. Iron wires catch fire and burn away, and tin burn very vigorously with vivid colors. Yeah, just stronger oxygen means a greater combustion and electrical effects. Now, if chemical action here is reduced, it becomes distinct from combustion. For with electricity too, vigorous combustion occurred, but as a melting by heat, not as a decomposition of water.
Hi, where are you?
Virtually chemical action is increased and electrical action diminished if the plates are smaller in it but more are used. 1,000 pairs, for example. The two activities are also combined so that the water is decomposed by a powerful electrical discharge. Yeah, that is a dialectical relationship right there, isn't it? You can
Yeah.
do more of one and less of the other because you're essentially biasing toward one of the two sides, so it just downplays the other. However, the two activities are also combined so that water is decomposed by a powerful electrical discharge. Yeah, if you build up
I go to
a large enough battery, both size and height, you're just going to get a big battery. Yeah, let me see if that means anything for us here. 254. Sometimes I do find it unfortunate some of these are still left in languages I don't have not read in a long time. The decomposed water, violently electrical discharges were initially passed through the liquid, however, producing explosions accompanied by sparks. However, Wollaston succeeded in producing the same effect in a far more pronounced, reliable electrical way by conducting the electric current into the water using braided wires terminating in sharp points. Oh, yes. Basically, different. I'm just trying to think that different ways of doing that. Now, since it's been observed that with water alone, chemical action is not strong in a battery, which, with a different construction, could produce strong chemical action in high electrical tension. Chemists have concluded that water here acts as an electrical insulator, which prevents the transmission of electricity. For since without this obstacle, there would be a strong chemical action, and the action here is weak, the inference is that the transmission of electricity, which gives rise to the chemical action, is prevented by the water. Nothing more absurd could be imagined, since water is the most powerful conductor, more powerful than metal. Not sure we're getting there, but this absurdity comes from attributing chemical action solely to electricity and from thinking merely in terms of conductors. You can
Yeah, exactly.
in science you do have to simplify so you can keep yourself in a certain realm, but there you do so at your own peril if you go too low. You get conclusions.
Yeah.
It's like if you keep subject and object apart through your entire process, you're going to get absurdities where subjectivity is only in your head and it does all this stuff that cannot know reality.
Yeah. I think Hegel talks about how um sort of I he doesn't talk about it like a Marxist. Like a Marxist, or at least a mid 20th century Marxist would call it bourgeois science, whereas Hegel called it science carried out by the understanding. I think that's the proper
Which,
term, something like that.
yeah,
And science carried out by the understanding is perfectly fine. It's just that it has to be reintegrated into a unity in which there are many differences, all of
it's
which count, and you can't just factor out. At the end of the day, when you're bringing it all together into one process, one unity of different processes, you, you have to stop doing science of the understanding and start doing science of the
it,
dialectic.
on a I guess more of a tangent. It reminds me, it's a lot. Some people, especially Scientologists, complain about psychology. Or what is it? It's like, yeah, doing psychology is fine, but keep the chemistry, like the sciencey whatever part. I can't remember if it's backward or the other. It's like not
Yeah,
mixing the chemicals with the psychological process or something. It's like, but that's the same thing. They're interrelated.
yeah, yeah, they are.
Because literally, yeah, the neurotransmitters is how your brain transmits signals, for goodness sake.
Yeah.
Yeah, talking again about galvanic action where you can is manifest both as taste and light. That's just because it's generating an acid or an alkaline on your tongue.
You know what? I have the feeling that when we start getting into philosophy of spirit, um, it's going to be getting into a lot of sort of the appearance of everyday human life versus what's actually going on,
Hmm.
and that's I'm interested to uncover like the more controversial aspects of that book. Um, I'm hoping they're just as explosive as some of the stuff here.
Now the product, yeah, that's getting more interesting. Anyways, now the product of galvanic action in general is that which itself has only notional existence, the identity of particular differences which in metals are bound up with their indifferent self-subsistence. It attains an existence as does the difference of one metal in the other, and the indifferent is therefore posited as difference because they finally react. Okay, that certainly makes a little more sense. The process still cannot go on to the production of a neutral substance, for there are still no existence differences. Now, since these differences are not yet bodies themselves, but only abstract determinants, the question arises, in what forms should they come into existence here? The abstract existence of these differences is elemental in nature, and we see it manifested as aeriform gaseous substances. Here then we have the speak of abstract chemical elements. Thus, because water is a mediating neutral term between the metals in which these differences can come into contact, as it is also in what the differences of two salts, example, are dissolved, it follows that each metal makes its existence different from water and determines water, on the one hand towards oxidation, on the other toward hydrogenization. Yeah, okay. It, these, yeah, they're indifferent to each other except through a third, and so that makes it become a physical, yeah, a realized difference. But since the character of water generally is to be neutral, the activating differentiating principle does not exist in water but in air. The air does indeed seem to be neutral, but it is the stealthily destructive activity the metals, therefore, must take from the air to the activity which they display, and that is why the differences appear in gaseous form. In this process, oxygen is the activating differentiating principle. The more specific result of the galvanic process is the oxide, a metal posited with a real difference. The first real difference we have, the indifferent body becomes a totality, although still not a complete totality. But though the product is at once also dual oxidation and hydrogenization, the outcome is not two differentiated bodies. On one side we have oxidation, example zinc is oxidized. The other side, the gold, silver, etc., holds out on its solidity against its opposite, retains its pure form, or if it has been oxidized, it is deoxidized. For sure. Oh, okay, yeah, that's right. On one end, the chemical reaction creates an oxide. The other side uses up the oxide, which then releases the pure metal. That's what I was saying earlier.
Yep.
The zinc gets eaten up. The copper, which is most common these days, would it kind of builds up on the copper piece. Since the activation of zinc cannot be the positing of as a one-side difference and can, on the other side, perhaps not be deoxidized, and the other side of the opposition appears only under the other form of water, namely as hydrogen. It can also happen that inside oxidized metals, hydrogenized metals are produced, a fact established by Ritter, but specific difference as opposition is alkali and acid, something different from that abstract differentiation. But even with such a real difference, the opposition is mainly brought about by the oxygen. To the metal oxides which result from the galvanic process also belong the earths, silica, calcite, barite, sodium, potassium, where the earths have in general metallic taste. It has been possible to demonstrate the metallic nature of these bases, although many have only slight indications of a metallic base. Now, through its metallic nature, it can always be preserved in its independence, as happens with metalloids. It is exhibited in amalgams of mercury, and only metallic substances can form amalgams of mercury. In the metalloids, therefore, metallity is only a moment. They rapidly become oxidized again, or, from example, being obtained in its pure state only with difficulty. Simplest noteworthy feature of ammoniac. Okay, I guess these are more things I don't recall these. Ammoniac, so ammonia maybe, is that one hand, it can be demonstrated that its base is nitrogen, its other constituent being hydrogen, but also that is a metallic. Yeah, that's just. But also that has metallic base, ammonia. Here, the metallicity is carried to the stage where it's. Yeah, I think some of these are older term usage of the original use of the terms that's confusing
Yeah.
me. Because ammonia is the gas, it's nitrogen, hydrogen. And whatever this metallic version of ammonia is, it must be something. The
Yeah.
process term. Go ahead, sorry.
No, no, you're fine. I'm just trying to puzzle it out along with you, and I'm like, what would that be?
The process term.
Something sulfuric, maybe, or sulfur light. I don't know. Anyway, I'll shut up.
That's all right. I'm just checking something, but then I'm going to like modern substances. So a solution of sodium in liquid ammonia is known. Maybe it's just talking about a metal. Yeah, there is metallic ammonia, but it's like apparently more complex than anything here. So the
Yeah.
process terminates in the production of oxidization. The opposition to this first abstract general negation is a free negativity, self-subsistent negativity in contrast to negatively paralyzing the indifference of the metal. The opposition is necessary in principle or in conformity with the notion, but its existence as fire is brought about contingently. Yeah, I see that pivots because oxidization is the biggest point because that's I believe even in the galvanic batteries the first reaction is the oxidation of zinc. So, and of course, what else does oxidation lead to? It's a combustion. Which at this point, I don't think they had the idea of plasma yet. I just want to kind of think about that as we go through the next section. All right, I want to give you guys a second to think about anything else. Any comments?
I mean, it's just going to go. It just continues on with the process of fire.
No, I mean before, because yeah, because I think we hit our time, right? So that was our
Yeah.
rating actually.
Covered the first of Hegel's three syllogisms of chemistry. First one being galvanism. And the second one would be fire neutral.
The third one is water or
Yeah.
neutralization, and the totality of those three processes in one,
Well, with
which then
yeah.
leads into disassociation, which I guess is the opposite direction we think of those. Yeah, I think that's what we were doing. Let me just double check from my end. How many pages is that total? So we're starting at 257. And if I go to the end of chapter, that's 272. That's less than less than 20 pages. Did we want to try just to finish the chapter at this point, or do you want to pace that a little bit?
Let's continue to pace it.
Yeah. So I'd say still keep that in mind, but maybe let's say we half that because that's what I was thinking about doing here. So halfway through this is 266. So let's see what. Yeah, which is what I thought. So I was correct. This is where we want this to pause right here. That's about halfway through. What's left? So let's read the other 2 points and then their intertwining of the I guess the galvanic, the fire and water, and then their interrelationship, and then we can stop there.
Yeah, sounds good. I need to reread the previous section again just to solidify it a little bit more in my head, and I want to read through what you posted, sort of showing the process of the wet battery.
Yeah. Um, it shows a lot because it's different. It's the two different sides of it, I guess, that you're seeing, and there is an actual like circuit because whatever the zinc that comes off or the as the zinc gets eaten up, I guess yeah, I've already confused myself, so I have to re-review it myself too after this.
Yeah.
All right.
All right,
Well,
comrades, you have a great night,
yep. Thanks. I
and
guess we all survived the winter storm.
the
Fern.
snowpoc this yet another snowpocalypse.
Yeah. For Oklahoma, we got like I think got like 8 to 9 inches where I'm at, which is a lot for Oklahoma.
We got probably around 18 inches.
Yeah.
Massachusetts.
Nice.
I I might already send it to Doug. I might send it to you guys too. The example of Oklahoma drivers in the snow. I guess there's always idiots anywhere, but it's
Oh yeah,
particular around here.
Corey saw all of them today. She's a registered nurse and she has to go even during level 3 emergencies. And yeah, there were people out that really didn't have any business being out.
Yeah, so it's everywhere.
It's one of those weird things, you work at a medical facility where people come to get their cancer treatment that technically they shouldn't be out in a level 3 emergency because they're not essential personnel, but essential personnel serve them. So like do the math for me on that. Like, you know, but there were a lot of people who came to get treatment despite the level 3 shutdown. So whatever, I guess.
Yeah. All right.
All right, cool. Well, comrades, you have a great night, and we'll continue to talk on chat and try to
Yeah.
um, galvanic pile. I need to look this stuff up.
Yeah. All right,
Have a
y'all.
good